Okay, so this section is the start of a new section, and it's going to take a look at making decisions in Java. And we're going to start off by looking back a couple of lessons, and we're going to review the original car park example that we looked at. Now, if you can cast your minds back, the car park example had two methods. One called car in, where we added one onto the number of cars going into the car park, and we had another method called car out, which removed a car from the car park. So it, in terms of the calculation, it just basically did a -1. That was okay, but there's still a couple of problems that we need to look at. And the first one was how many cars are actually allowed to enter the car park, because car parks aren't infinite spaces. And the second one is what happens when all the cars have left the car park, because if you have an empty car park, you can't remove any cars from it because there aren't any cars in there in order to remove them. So let's have a look at the car park example, original car park example, and then we'll have a chat about it. Okay, so I've got the original car park program open in BlueJ. I've already, for speed, created an instance of the car park class. So if we open it in the inspection window, and we'll have a look at the instance variable mnumCars just to inspect its state. If we call the car in method, you can see that we've added one onto mnumCars, and obviously I can keep calling car in almost indefinitely. Doesn't really model the action of a real car park. We've only got 5 spaces, for example. I can go beyond that, and obviously that's not very good. The same applies with car out. It's actually a slightly worse situation with car out, because if I call car out, it will remove a car from the car park, but it's going to reach a point where I have one car left. I remove it, so we've got an empty car park. But if I call car out again, we reach a situation that we shouldn't really be reaching, in which case we can't have -1 cars in a car park. So there are two issues that we need to address. One is the maximum number of cars in the car park, and two is having a test on if our car park is empty. So let's have a look at how we can fix that. Okay, so let's look at our problems in a bit more detail. In a real car park, the number of parking bays is always limited. There are only so many cars that are allowed in. So to keep things nice and simple, let's say our car park's only got 5 bays. So we're actually restricting the number of cars in our car park to 5. If any more arrive, we display a message that basically won't allow these people in. So our car in method has to go through some kind of decision making process. We still have the original instruction, whereby when a car comes in, we add one onto the number of cars in the car park, but we need to now incorporate some kind of a decision statement, and it incorporates an if. Now, obviously you should have done if statements in other languages, but if we say it in reasonable English, if the number of cars in the car park is less than the maximum number of bays, then we can increment the number of cars by 1. And that's what it looks like in Java. Like a lot of programming languages, it's a standard if statement. The if statement contains a condition, and the condition in this particular case is if the value of mnumCars is less than the value that's in bays. Now, taking on our previous learning, bays is written in capital letters, so that'll tell us that it's a constant. So if the value of num cars is less than bays, which basically means if there's room in the car park, then we can add one on to the value of num cars. And you can technically replace that with m num cars plus plus if you wanted to. The second problem deals with when cars are leaving the car park. Under normal circumstances, we reduce the number of cars by 1, we decrement by 1. But as you've already seen in the example, if the number of cars is 0, we can still remove a car that's non-existent, which takes our value of m num cars to -1, which we can't do. So what we need to be able to do is restrict that by only allowing a car to leave if there's a car that's in there in actually to make it leave. So in sort of English terms, if the number of cars is greater than 0, then we can decrement the number of cars by 1. So a little stop and try out exercise. Have a go now at writing the decision statement to ensure that car out can only process a car leaving if there are cars in the car park. And as a guide, the English statement should help you a lot. If the number of cars is greater than 0, then we can decrement the number of cars by 1. Pause the video, take a couple of minutes and have a go at that exercise. And there's a solution. Okay? If the number of cars in the car park is greater than 0, then we can actually remove a car from the car park. And let's have a look at that working in our car park 2 example. Okay, so I've opened car park 2 in BlueJ. So let's just have a quick look at the code first in the editor, and then we can examine what's going on. So again, takes on a lot of our previous learning. Our car park 2 class, first of all, we've declared a constant called bays, which we've set to 5. So that means we've only got 5 bays in our car park. We've also got the instance variable m num cars, which is tracking how many cars are in the car park. And when we create an instance of our car park, we set the number of cars in there to 0. When we get onto the methods, we've got our 2 if statements. So if we look at the car in method, if the value of m num cars is less than the value of bays, which is 5, so if we've got room effectively, we can add 1 onto m num cars. For the car out method, if the number of cars in the car park is greater than 0, namely, are there any cars in there that allow us to take one out to allow one to leave, then we can remove 1 from m num cars. So let's give it a compile with no syntax errors. So let's give it a test. Create an instance. We'll open it in the Object Inspector. Notice that we've got our constant declared, which obviously we can't change, and we've got an empty car park from the initialization in the constructor. So let's just fill our car park up. So add 1, 2, 3, 4 and 5, and at this point the car park's full. In the old version we'd just be allowed to keep adding cars, it would go beyond 5, but remember this version has got our if statements in it, so what we can do is attempt to drive a car in, but it's not changed because the value of cars in the car park is the same as the number of bays, and we can't add any more cars to the car park. So that it obviously proves that the if statement that we've used on car in works. What we're going to do is we're going to now test car out. So again, we'll do the same. So we go from 5 to 4 to 3 to 2 to 1. one car in the car park, which we can remove, which means we've now got an empty car park. If I attempt to remove another car, we can't, because the number of cars in the car park are 0. We can't remove a car that isn't in the car park. Okay, just a little note while we've been looking at our first instances of our if statements. Take it as a bonus that Lec4A actually allows us to automatically indent our code statements inside the curly brackets of an if statement. It's worth just taking your time just to make sure that your if statements, or your code in your if statements, is actually indented properly. It's easier for you to understand what's part of the if statement, but at the same time, this code, which needs to be read by the likes of lecturers, and possibly you might want to use it again, just makes it a lot easier to read if it comes to looking at these programs in the future. So when we look at conditions, the if statement always has some kind of a condition where it's a question for which the answer will either be true or false. So at the minute we've looked at two condition types. The first one uses a less than, so if the number of cars is less than the maximum number of bays available, and the other one was if the number of cars is greater than 0. In both cases they will produce either a true or a false statement. There are lots of different types of condition, but there are also lots of other conditional operators that you probably already know, some that you might not know. So what we need to do is basically have a little bit of an examination of some of Java's weird statements that you might not have come across. One of them is the equality condition, and you have to make a differentiation between a test for equality and assignment, and they're very different and they're used in different contexts. If you're testing for one value being equal to another value, then what we do is we use two equal signs. If we're assigning a value, i.e. for example we're setting the value of x equal to 10, then we use the assignment operator, which is one equal sign. Now the way that you would probably remember it a little bit easier is that assignment is about setting values, and the equality condition is only generally used in if statements for testing if two things are equal, and it only tends to be used in if statements. So let's have a look at a little program to give you an idea of how that would be utilized. Okay, so I've opened up the project called Age off the VLE, and the first thing that you might notice is that in this version of Lec4A we've not got the non-compile hatch marks like we have with the user class. We've actually got the red cross elements, so we need to have a look at that and see what we're actually meaning by that. So we're going to attempt to compile it, and straight away if we have a look at the code, we've got an error that's been detected, and in this particular case the error has actually been flagged up on this line, and as you can see it's saying that it's found an error in the class. It's not exactly telling us what the error is, but if you actually have a look at it in context, it's actually saying if the value of age is equal to 5. But the problem that we've got, if you think about what we've just said, is that in an if statement a single equal sign isn't a test for equality, it's an assignment. If we were to take that value out of there, and let's say we just put it underneath there, that's a perfectly acceptable line of code. it would get the value of 5 and put it in mage. But we don't want to do that. We need to test in this particular example to see if the value of mage is equal to 5. We're not setting it to 5. So in order to fix this particular problem, we have to use two equal signs. Now we find if we compile it, it's compiled with no errors. So straight away there's a worked example there of the difference between assigning a value, one equals sign, to comparing two values, which is what you would do in an if statement, with two equal signs. So we can go back now and we can have a look at how this program actually works. It's a pretty short program, class called age, and what we do is initially in our constructor we set the value of age is equal to 0. The method called birthday will add 1 onto the value of age and then use the user class to output a message to say your age is whatever the value of age is. Once we've output the message, it then performs an if test on the value of mage. And if the value of mage is 5, it will then say you are now old enough to go to school. So again, we'll have a quick compile just to prove that everything's working now, and we'll create an instance of the age class and we'll inspect it. And initially in the constructor we should have set it to 0, and what we're going to do is I'm going to call birthday and we get the message that the age is 1, and that changes in the inspector. We get another birthday and somebody's 2, tells us that, tells us that it's 3, it's affected in the variable, tells us it's 4, and then this one we will add 1 onto age, but then we should get a true when the value of age is equal to 5. So in the first instance it tells us that our age is 5, and it then tells us that we're now old enough to go to school. So a lesson to learn from this particular element is that it's the double equal sign to check for values in an if statement. Okay, so just to act as a quick summarization of that, the difference between one equal sign and two equal signs. You don't use a single equal sign in a condition. One equals is about assignment. X equals 10, A equals 5. You put the values into those variables. Two equal signs used for comparing. If X is equal to 10, if A is equal to 5. It compares the values and it returns true or false, but the values in the variables don't change. So let's have a look at some of the other conditional operators that are used in Java. You probably find that you recognize things like greater than or equal to, less than or equal to. They're pretty standard. You've already seen assignment, which is one equal sign. You've already seen equal to, which is two equal signs. One that you may or may not have come across, depending on your experience in other languages, is not equal to. This is actually the same not equal to that's used in languages like PHP, but in other languages such as VB, you might find that your not equal to sign looks like two chevrons facing away from each other. It does depend entirely on the language, but for the sake of Java, that's the sign that we use for not equal to. Okay, so what we're going to do is go back to our original car park example, and we're now going to sort of expand it a little bit more. At the minute, we're in a reasonable position. We can allow users only to enter our car park if there's room, and if there's no room, then we can actually tell people that there is no room. But we want to expand it a little bit, because at the minute there's no interface to our system. If the number of cars in the car park is less than the total number of bays, then we just add one on. But if we can't allow a car in, we can't tell the user that the car park is full. So we have to expand it just a little bit more. So what we do now is we apply an else statement. And again, those who've programmed before will be used to using else statements with ifs. If the value of mnum cars is less than the number of bays, i.e. we've got room, we can add one onto the number of cars. If the case of that particular condition is false, then we run the else. In which case, the number of cars is not less than, it's either greater than or equal to, in which case we send them a message and say that the car park is full. So let's have a look at that in car park 3. Okay, so I've opened car park 3 in BlueJ, and let's just open it up in the editor and see what it looks like. I know it's different from other versions that we've done before. Okay, so let's look at what we already know and what's not changed. The constant for the number of bays in the car park is the same. The mnum cars variable declaration is the same, and we initialize num cars to 0 in our constructor. The difference is now in our car in, whereby if we attempt to enter the car park and the number of cars is less than the total number of bays, then we're allowed in. If the car park is full, then the answer to this will be false, and we output the message car park full. For the minute, car out has not been altered, so we'll just test car in. We'll compile it and we'll create an instance and we'll inspect it and we'll go through the same again. So car in, yep, in all these cases we've got room in the car park because num cars is less than the value of bays, and we'll keep adding cars up to the point where the car park is full. But if we attempt to add another car, we get the message that the car park is full. Okay, so a little note now about code layout when you're using if-else statements. Again, BlueJ is quite good to us in that it does automatically indent a lot of code inside the brackets used in if and else statements, but just be mindful that you need to maintain this in order to maintain the readability of the code, certainly if you're going to come back to old projects after a long time, or you're presenting code to lecturers for marking. Just think about that in order to make your code readable. So let's make this a little bit more challenging. We've got an if-else decision, and that gives us two alternative choices. If the decision is true, we go down one route, and if the decision is false, then we go down the other route. We can add any number of else-if statements between an if and an else. And again, this is something that you might have done in a slightly different way in other languages. The rules of the execution are the same. If a condition is true, you run the true statements. If they're not, what you do is you move on to the next condition. And the else statement doesn't have a condition with it. If the answer to all the previous conditions are false, then it will just do what the else statement wants us to do. So it allows us now to incorporate multiple tests and multiple conditions into our programs. So what we could effectively say, if we have a look at this one here, is that if this particular condition is true, perform the statements between these two curly brackets. If that's not true, then if this condition is true, then perform all the statements in these brackets. And technically, you can repeat the number of else ifs that you need. You could put 3 or 4 or 10. It doesn't make any difference. You have a separate else if statement with its associated code statements for every condition. But if that one's false and that one's false, and maybe you've got a couple of others that are false, the last one will always be just else. The else at the end is optional, but it's a good idea to have it in because it acts as a bit of a trap. Because if none of these previous conditions are true, then at least you put an else in there that will trap it and at least give the user some indication that you're going down this particular route. We'll have a look at that in this next demonstration. So I've opened the project called temperature, which is on VLE like all of the others. So let's just open it in the editor and inspect the code. So little bit longer, but not too much of a longer program. Reasonably straightforward though. We've got a class called temperature with a single instance variable, which is an integer called temperature. And the constructor, same name as the class itself, is initialized to 15. And if we call the method called hotter, it adds 10 to the temperature. And we have a method called colder, and if we call that, it will take 10 off the temperature. So we've got the ability to change the temperature up and down in blocks of 10 degrees. We've also got a method, quite a big method, but if we call this method, which is called read thermometer, we have 1, 2, 3, 4 conditional statements. Now the order of the conditional statements is important, and the general rule, especially when you're dealing with numbers, is to go from highest to lowest. Okay, so in the case of us calling the method called read thermometer, if the value of temperature is greater than or equal to 30, it will say it's very hot. If the temperature is not greater than or equal to 30, then you go to the next band. So if the value of temperature is greater than or equal to 20, it'll say it's warm. If that's not true, and the value of temperature is greater than or equal to 10, it'll tell us it's mild. And if the answer to that's false and the temperature is greater than or equal to 0, it'll say that it's cold. If the value of temperature doesn't meet any of these criteria, for example, it's negative, like -5, well, -5's not greater than or equal to 30, it's not greater than or equal to 20, it's not greater than or equal to 10, and it's not greater than or equal to 0. So it doesn't meet any of these criteria, so that's when the else with no condition will run, and it'll tell us that it's freezing. So we'll compile that, and we will inspect. Well, let's create an instance first. We'll inspect that, and let's see what happens. At the minute it's 15 degrees, so let's take it from the highest to the lowest. So let's make it hotter by 20 degrees and read the thermometer, and it will tell us it's very hot, it's greater than 30. Let's knock it down by 10 degrees, and it now tells us that it's warm, so it's met the second condition in the program. Let's make it cooler by another 10 degrees, and it will now tell us that it's mild. Another 10 degrees, it's now telling us that it's cold because it's greater than or equal to 0. And this is where we're going to hit the else without the condition, we're going to make it a negative temperature, and if we read the thermometer, it hits the else and it tells us that it's freezing. Okay, so just to summarise, we've used 3 types of if statement. We've looked at if with a condition, we've looked at if with a condition and an else that gives us 2 paths through a program, and then we've looked at a new type of structure which allows us to put more than one condition into a program using if and multiple repeated else if statements, each with their own condition, and a final summary else if none of the conditions are true. And then we've looked at some of the conditional operators that are available in Java. So we've got the equality condition, not equal to, less than or equal to, greater than, and greater than or equal to.